In this problem, we're going to use proof by contradiction. Suppose that y plus x is equal to 2y minus x, and x and y are not both 0. Prove that y is not equal to 0. If you think about this, if we know that x and y are not both 0, and we want to show that actually y is not 0, then it would be enough to show that x is 0, right? Because then y would have to be the one that's non-zero. So maybe that's going to come up at some point in our proof. But let's just try and build it up from the start. Here are our two givens, and our goal is y not equal to 0. And because this is a negation of the statement y equals 0, proof by contradiction is not a bad idea to try. Okay, so for that, we will take as given the negation of our original goal, and our new goal is to derive some sort of contradiction. So we can bring down our other givens, and now thinking about how to combine the givens, we could right away say that x is not 0, but let me instead just combine the two equations. Okay. Since y is 0, I can substitute 0 for y in my first equation here, resulting in just x equals negative x. And that's something I ought to be able to solve for x. Right? So if we add x to each side, we get 2x equals 0. And then dividing each side by 2, we get that x is 0. And now we're pretty much done, because we know that x and y are both 0, and we have a given that says that can't happen. So that's a contradiction. So let's write this out in a proof. Suppose for contradiction, remember to tell your reader what type of proof you're doing, that y is equal to 0. And what do we do? Substituting y equals 0 into y plus x equals 2y minus x, we get x equals negative x. And then the next two steps were both pretty simple. Maybe I can combine them into a single line here. Adding x to each side, and then dividing each side by 2, we get that x equals 0 as well. And this contradicts our given, right? The fact that x and y are not both 0. So we're done, and we can sum it up by saying, therefore, y is not equal to 0. We supposed it was, we got a contradiction, therefore it's not.